So this is now our first example whereby you've been told y is equal, a function y is equals to what we have here. So the first thing that we need to understand is the introduction of law, is the observation of laws of logarithm. And by introduction of law of logarithm, we are going to have the natural log of y is equals to the natural log of everything in bracket So this is our first step. After the introduction of the natural log, we are going to distribute the natural logs into each and every term, and by distribution of the natural log, we are going to observe the laws of logarithm. So here we are going to have the natural log of y is equals to, here we are going to have the natural log x, we subtract from 2. Since this one is a multiplication, we are going to have our addition. We add to the natural log of x, we add to 1. And lastly, we come and subtract from, this is our numerator. We subtract from the natural log of x, subtract from 1. We add to the natural log of x, we add to, we add to 3. After the introduction of the natural log into each and every term, now let us do our differential, the differential coefficient of logarithmic function. So when it comes to the differential coefficient of this logarithmic function, we are going to have, for example, you can have the natural log of x is equals to 1 all over x. This one means that we are going to take this term as our u. So for us to differentiate a natural log, it is always the differential of the term of u all over the term of u. Here, our term of u is equals to 1. To mean when we do our differential with respect to x, we are going to have 1 all over the term of x, which is equals to u. So this is how we do our differentials of natural logs. So let us come here. When we do our differentials with respect to this one, we are going to have the natural log x so our differential with respect to this one, we are going to have u prime all over u. When we do our differential, this is our term of, we take this one as our term of u. When we do our differential with respect to this one, we are going to have 1. The differential of this one is equals to 1. The differential of this one is equals to 0. All over x minus 2. So this is how we do the differential of the natural logs. So here we are going to have 1 all over x minus. Now let us come to this one. We add to the differential of this one, we are going to have, we are still going to have the whole of this one as our term of u. And when we differentiate this, we are going to have 1 all over x, we add to 1, we subtract from The differential of this one. The differential of this one, we are going to have 1 all over x minus 1. We add 2. The differential of this one, we are going to have 1 all over x plus 3. Now, let us come to our natural log of y. We say that the differential of an implicit function. So it was a y function. So here we are going to carry out our differential here implicitly. And by differentiating this one implicitly, when we differentiate y, we are going to have 1 all over y. But since it was differentiated implicitly, we are going to have dy with respect to dx. Now, after differentiating up to this point, after differentiating up to this point, this negative is going to affect what we have here within into our second bracket, and we are going to have 1 dy with respect to dx is equals to, here we are going to have 1 all over x minus 2. We add 2, 1 all over x plus 1. We subtract from 1 all over x minus 1. When we open the bracket here, we are going to have 1 all over. Since it was differential of a logarithmic function, we are going to have dy with respect to dx here and take the term of y to the other side. And by doing that, we are going to have dy with respect to dx is equals to y multiplied by everything within the bracket. So here we are going to have 1 x minus 2. We add to 1 x plus, we subtract from 1 x minus this, and lastly we are going to have 1 all of x plus 3. But from here now, we have y is equals to everything on the other side after doing your differential. But we say that y was equals to this function. So we are going to replace y with the term of x minus 2 multiplied by x plus 1 with the whole of this one. So we are going to have here now we are going to have dy with respect to dx will be equals to the whole of this term, because y is equals to what we have here. And now we are going to have this one as a term of y. We are going to have the whole of this one as a term of y. We multiply by whatever we differentiated. So here we are going to have So this is what you are going to have as your answer. This is what you are going to have as your answer when you do your differential of this logarithmic function.